Example 2, we are saying f prime of x is given by the limit as delta x tends to 0 of the function, then you subtract off the original function. We proved this one here earlier of this. So in this case, our function we have is a 1 minus x squared. So what are we going to have? We are going to write it as 1 minus. Now, wherever there is x, I put the x plus delta x. So it is x plus delta x. But now my x on the original is a squared, so I put a squared there. Then minus, my original equation is 1 minus x squared over delta x. This is the limit as delta x tends to 0. So we are saying the lim as delta x tends to 0 is given by, we can expand this, we shall have 1 minus, when you open brackets it will be x squared plus 2x delta x then plus, then this is minus, because this is the whole function, it's a minus 1 plus x squared. Now all of this is divided by delta x. I'm going to open brackets here, and I'm saying that the f prime of x is the limit as delta x tends to 0, and I have it as 1 minus x squared, then this is minus 2x delta x squared, then minus 1 plus x squared. All of this is divided by delta x. This one, of course, is going to cancel, and this, most of the times, the original equation like it was has to cancel out. So the 1 minus x squared has cancelled out. Then I'm remaining with the limit as delta x tends to 0, and I have remained with negative 2x delta x minus delta x squared. All of this is divided by delta x. So what we are going to do is divide by delta x on each term. So I'll remain with the lim as delta x tends to 0 of negative 2x then minus delta x. Now, if I have delta x remaining in my function, we are saying delta x is tending to 0, so this becomes what? 0. So this implies that f prime of x is simply going to be the limit as delta x tends to 0 of negative 2x. So therefore, the f prime of x of our equation 1 minus x squared is simply going to be negative 2x.